Hello, welcome to this interdisciplinary science course. Science is an integral part of our life. Scientific principles and scientific method will broaden your outlook, sharpen your thinking, and will make you good problem solvers, which is essential for life. Science has shaped modern life so much that without the understanding of basic principles of science, it is difficult to interact meaningfully with the rest of the world around us. So I hope that you will treat this course not just as a degree requirement, but as an essential part of your intellectual and social growth. I want you to enjoy this course and pass on the enjoyment, the joy of learning science, doing science, experiencing science, and actually living with science to people around you. Science is a joy to interact with. All right, we will start this course with a discussion on measuring fundamental quantities. You see, measurement, we live in a world of measurement, and an understanding of measurement is therefore essential for an understanding of science. When you talk about measurement, now what we measure in America must be understandable to everybody else who live in Europe, in Asia, in Australia, anywhere else in the world. Therefore, we need to standardize measurements. And in order to standardize measurements, we use units for measurement. Well, you know that unit for our currency is a dollar, and we all understand the meaning of $1. Well, do you know the meaning of €1? Well, 1 peso, 1 yen, 1 rupee. Well, we got currencies all over the world. In science, we have 3 fundamental quantities, and the units of those fundamental quantities are called fundamental units. Well, what are these 3 fundamental quantities? The fundamental quantities are length, mass, and time. If you can measure these 3 fundamental quantities, then everything else can be measured using those quantities. And therefore, the units for measuring length, mass, and time are called fundamental units. Now, there are other fundamental units which are units of temperature and electric current. Well, at the moment we are going to concentrate on the units of measuring length, mass, and time. Now, all other units can be obtained by combining these fundamental units in some form, and therefore these kind of units will be called derived units, derived from fundamental units. For example, the unit of speed. Speed, you know, we measure it miles per hour in America, and elsewhere it is kilometer per hour. Density, now these are derived from fundamental quantities. So for this reason, these quantities are called derived quantities, and the units of these quantities will be called derived units. Alright, what is the unit of length? Does anybody know what the unit of length is? How do we measure length? Internationally, length is measured using a unit called the meter. Now, I'm sure most of you have seen a meter stick. Now, here is a meter stick, and this is 1 meter. And you know that a meter is divided into centimeters and millimeters. I will talk about that in a minute. So the unit of length is the meter. The unit of mass is the kilogram. Now, how much is a kilogram? I'm actually holding a mass which is 1 kilogram. This is 1 kilogram. Internationally used unit for measuring mass is a kilogram. Alright? And finally, the unit of time is the second. That everybody knows. The unit of temperature is Kelvin. Well, we use Fahrenheit, Celsius, but internationally and scientifically we use Kelvin, and we will see that as we move on. Well, let's talk about the unit for measuring length. The unit for measuring length is the meter, and look at the abbreviation. We use small m, lowercase m, to represent a meter. Now, the following is a summary of units for measuring small and large distances. Well, you know this is a meter. Now, can you use a meter stick like this to measure the diameter of your hair or thickness of a paper? No, you cannot. That means you need to divide this into smaller parts. Also, if you want to measure the distance from the earth to the sun. Now, does anybody know what that distance is? It is an important distance called an astronomical unit. It is 150 million kilometers. Well, obviously, it means you need a bigger unit for measuring such large distances. Well, I want you to look at these terms that I'm using. Now here, we start with this, a meter. Now, once you have a meter, which is the basic unit, if I take you to the left, what I'm going to do is call the meter equal to 1 meter. And look at the way I'm writing it, 10 raised to the power of 0. You know that any quantity raised to the power of 0 is 1. Now, the most important principle in metric system is that the metric system, everything comes in multiples of 10. Very easy to use. So I'm going to start by calling the meter 10 to the power of 0, and that is 1 meter. Now, what is a decimeter? A decimeter is 1/10 of a meter. And look at the way we write 1/10. 10 to the power of -1. I hope you know that. 10 to the power of -1 is 1/10. 1/10. That is a decimeter. What is a centimeter? 10 to the power of -2. You know that 10 to the power of -2 is 1/10 to the power of +2. Is that right? Elementary algebra, which is 1/100. 100th of a meter. Centi means 100th. So a centimeter is 100th of a meter. How about millimeter? Milli is 1,000th. How will you write milli then using base 10? It will be 10 to the power of -3. That's the way we write 1,000th. So millimeter is 1,000th of a meter. Micrometer is a millionth of a meter, 10 to the power of -6. Nanometer is a billionth of a meter. Isn't that interesting? Have you heard of nanotechnology? Technologies that make use of very, very small quantities. Nano. 1 billionth of a meter. And finally, a picometer is a trillionth of a meter. So what we were doing is going into smaller and smaller and smaller and smaller units. Now, a nanometer, the diameter of an atom, is of the order of a nanometer. Let's now go to the right. As we go to the right, we're going to get bigger and bigger units. What is deca? Deca is 10. A decade is 10 years. So that is 10 to the power of positive 1. Deca. What is hecto? Hecto is 100. That is 10 to the power of 2. A hectometer is 100 meters. What is a kilometer? A kilometer is 1,000 meter. A megameter is a million meter. A gigameter is a billion meter. What is a gigabyte? You all carry these flash drives, 1 gigabyte or 2 gigabyte. What is a gigabyte? A billion bytes. A gigameter is a billion meter. And finally, a terameter. It's interesting to know these terms, right? Okay. Now, 1 millimeter, as we just said, is 1,000th of a meter, 10 to the power of -3 meter. That means 1 meter contains 1,000 millimeter. Look at the way I wrote 1,000. 10 to the power of +3. So this meter stick contains, actually, this is divided into 1,000 parts. You can actually see them in there. A meter stick contains 1,000 millimeters. Similarly, a centimeter is 100th of a meter. Look at the way again we write 100, 10 to the power of -2. And therefore, a meter contains 100 centimeter. Well, here again, if you look at the meter stick, you can see they are marked in centimeters. Starting from here, 1 centimeter, 2 centimeter, all the way to 100 centimeter. A meter is made up of 100 centimeter. A kilometer is 1,000 meter. Now these three are the most commonly used, although you don't remember others. But it is interesting to know these. But the millimeter, centimeter and kilometer we will be using as we go on. How about measuring units, the units of mass? What is the unit of mass I told you a little while ago? I told you it is a kilogram. That is a kilogram. But very often you need to measure small masses and also great big masses, like the mass of the earth, the mass of the universe. Is that right? Now, small masses like the mass of an atom. All right. Now, when you go and take a prescription medicine, have you seen or heard about milligrams of medicine? You see, very often medicines are rated or measured in milligrams. So, let's look at that. A kilogram is written kg, lowercase k, lowercase g. Now, don't use uppercase k for it. Kilogram, lowercase k, lowercase g. For measuring small and large masses, we use the same names. Now, come here. This is our kilogram. That is the unit, the standard unit. Now, if you start at a gram, now, when you start a gram, what is a picogram? What is a picogram? If you remember those, 1 trillionth of a gram. A nanogram is 1 billionth of a gram. A microgram is 1 millionth of a gram. A milligram, which we very often use, is a thousandth of a gram. A centigram is 100th of a gram. And a kilogram is 1,000 gram. Alright? Now you don't worry about many of those, but we will use kilogram, milligram, gram. Alright? 1 milligram is 1,000th of a gram. Look at the way again, 1,000th. 10 to the power of -3. And 1 gram is 1,000th of a kilogram. That means 1 kilogram contains 1,000 grams. So the kilogram, just I showed you, this kilogram mass contains how many grams? This contains 1,000 grams. Now don't forget that. I will be asking you as we go on. A kilogram is made up of 1,000 grams. In fact, that's the only unit that we will be using in all these names. Alright, we talked about the fundamental units. Of course, the unit of time is the second. Now, units of area and volume are derived units. What is an area? If you want to find the area of a piece of paper or something like this. Now, how do you find the area of a block like this? To find the area, you measure the length, measure the width. Tell me, what is the unit you will use to measure the length? Length will be measured in meter, width will be measured in meter. Therefore, what will be the unit for measuring area? Area is length multiplied by width, that is meter multiplied by meter, that is a square meter. So the unit of area is a square meter. When you measure length in meter, the unit for measuring area is a square meter, meter squared. Now, have you heard of a hectare? What is a hectare of land? In America, we use an acre. Well, a hectare is actually bigger than an acre. You see, a hectare is 10,000 square meter. In other words, if you can consider a piece of land 100 meter long and 100 meter wide, that area will be a hectare. Can you figure out the football field? Is it greater or smaller than a hectare? Well, the football field is actually smaller than a hectare. Alright. When length is measured in centimeter, very often we measure length in centimeter, then your area will be in centimeter squared. We call it square centimeter. When length is measured in meter, what is the unit of volume? How do we calculate the volume of a piece of wood like this? Now, this has a length, a width, and a height. You see that? It has got a height, a width, and a length. To calculate the volume, what do? Multiply the length by the width and then by the height. So the length is measured in a meter, width is measured in meter, height also is measured in meter. So volume will be a meter multiplied by a meter multiplied by a meter. We call it the cubic meter or meter cube. So when length is measured in meter, the unit for measuring volume is a cubic meter. Alright? In the same way, if you measure length in centimeter, the unit of volume will be a cubic centimeter, or we write centimeter cube. Now, a common unit for measuring volume is a liter. I'm sure you have heard about it. We know a liter of wine. You can even buy whiskey in liters. Your water bottles, you see, if you buy a bottle of water and look on it, it is written 385 milliliter. Now, what is a milliliter? A milliliter is a thousandth of a liter. So 385 milliliter is 385 thousandth of a liter. Is that right? Okay. 1 liter, I want you to learn this one. 1 liter is actually 1000 centimeter cube. Alright, let me ask you this. How many milliliters are there in a liter? Milliliter. A milliliter is a thousandth of a liter. So how many milliliters are there in a liter? There are 1000 milliliters in a liter. And also I just showed you there are 1000 centimeter cube in a liter. So what is the relation between a centimeter cube and a liter? I'm sorry, a centimeter cube and a milliliter. Anybody tell me what is the relation between a centimeter cube and a milliliter? 1000 milliliter is a liter. 1000 centimeter cube is a liter, which means 1 centimeter cube is the same as a milliliter. So when you buy a bottle of Coca-Cola which says 380 milliliter, the volume of the liquid inside there is 380 centimeter cube. A milliliter and a centimeter cube are both the same. So 1 centimeter cube is the same as a milliliter. Alright, we talked about units and we will be using them as we go on. Now, very often in sciences and in our everyday life, we use equations and variables. Now, what are variables? Well, equations are used to describe how one variable changes with respect to another. Can you give me an example for that? Alright, how does the amount of money you earn change with the number of hours you work? Have you ever thought of that? You enter a contract with your employer. Alright, you're going to be paid $10 an hour. That means you work for 1 hour, you get $10. You get 2 hours, you get $20. You work $3, you get $30. So look at that, the amount of money you earn is related to the amount of time you work. There is a direct relationship between the amount of money you earn and the amount of time you work. Now, we can represent the amount of money you earn by a variable. Now, give me a variable I can represent the amount of money. I can use A. Let A represent the amount of money and let T represent the time in hours. Can you write an equation that tells you how the amount of money you earn changes with the amount of time you work? Is it possible to write an equation? Well, it will look like this. The amount of money you earn, A equal to 10 times T. Is that right? Look at that beautiful equation. This is an equation that is written using variables. A stands for the amount of money you earn. T stands for the number of hours you work. You see? When you replace your T by 5, it tells you you worked for 5 hours. how much money you earn. 10 times 5, 50. If you work for 20 hours, tell me how much money you take home if you work for 20 hours. 20 times 10, $200. So here we have an equation that represents this particular relationship, the amount of money you earn and the amount of time you work. Okay, how does the distance traveled by a car change with time? If you keep driving, the distance covered by your car keep on increasing with time. You can represent that as an equation. Now, variation of one variable with respect to another may be a direct variation or an inverse variation. Now, what is the meaning of that? What is the meaning of a direct variation? A direct variation means when one variable increases, the other also will increase. When time, the amount of time you work increases, the amount of dollars you earn will also increase. That is a direct variation. Well, what is an inverse variation? The inverse variation is when one variable increases, the other will decrease. Alright, you go to the mall with $2,000 in your pocket. The more amount of time you shop, the amount of money in your pocket will decrease. Most of you know that very well. You see that inverse variation. As more you shop, less will be the amount of money left in your pocket. So the relationship between variables can be a direct variation or inverse variation. Now look at the example here. When you fill your car, when you go to the filling station, stand there and keep filling. With time, the amount of gas in your tank increases. Direct variation. Now, when you finish filling, close the gas tank, get into your car and keep driving. The longer you drive, the amount of gas in your tank will decrease. An inverse variation. So we live in a world of variation. Is that right? Everything around us actually is changing. Now, most of the changes can be classified as a direct variation or an inverse variation. But of course there are other very complicated variations too. We are not going to concentrate on those. And these variations can be represented by drawing graphs. And understanding the basic principles of science, you need to understand how to read and construct graphs. So that is an essential part of the skill I want you to learn. And I will be emphasizing that in our labs. Alright? So learn how we can produce a graph using variables. The variation of one variable with another can be represented graphically. For example, let's spend a few minutes talking about how the graph of your earnings with time look like. Alright, now I'm going to spend a couple of minutes. I'm going to draw a chart for you here. Now I'm going to make a table here. Alright, and the table will be the amount of time in hours, look at the way I write it, and the amount of money, A, in dollars. You work 1 hour, you take home, tell me how much money you take home. Well, let's keep it very low, $10. If you work for 2 hours, you take home $20. If you work for 3 hours, you take home $30. 4 hours, you take home $40. Alright, now most of you know how to draw a graph. A graph has an x-axis, is that right? This is the x-axis, and this is called the y-axis. Now, what we're going to do is, we're going to put the amount in dollars on the y-axis, and the time in hours on the x-axis. Alright, this is time 0, this is 1, that is 2, that is 3, and that's 4. And this is amount 0, this is amount $10, $20, $30, $40. Alright, can you help me mark the point? When time is 1 hour, the amount of dollars is $10. Look at that point there. Now we call this point time 1 hour, the amount of dollars 10. We call it an ordered pair. Is that right? I'm sure you know from your algebra that this is an ordered pair. The x value is 1, the y value is 10. Alright? Let's mark the other points. When time equal to 2, the amount of dollars, you see the time equal to 2, the amount of dollars is 20. This is the point. And what is that point called? It is called 2:20. When time is 3 hours, the amount of dollars is 30. This point is called 3:30. Is that right? That's the order pair there. When time is 4 hours, the amount of dollars is 40. That is the point called 4:40. And you can see this is a straight line. If you join all the points and look at that beautiful picture. You see, graph is a picture of this variation. The variation of one variable with respect to another can be represented by a picture, a graph. And you know that a graph has a slope. Do you know the meaning of slope? A graph has a slope. What is the meaning of a slope? Well, let me see if I can explain that to you right here. Now, after you work for 2 hours, you see, after you work for 2 hours, you decided to work for 2 more hours. That means the amount of time is going to be increased by 2 hours. So now look at the line I've drawn. From t equal to 2 to t equal to 4. What is the length of this line? The length of this line is 4 minus 2. Now, this is called the change in the amount of time. Now, the change in the amount of time. Whenever we represent the change in a variable, like the change in the amount of time, we will do it like this. Look at this, I want you to learn this. This is the Greek letter we call delta. Delta t. Delta t represents a change in the value of time. In that case, how do I write the change in the value of A? It'll be delta A, is that right? So, delta A will then stand for the change in the value of the amount of dollars. What does delta X represent? Delta X represents a change in the value of X. Delta Y will represent a change in the value of Y. Well, now look at this. What is the change in the value of T here, or what is the value of delta T? Delta T equal to, I'm going to write, can you help me write it? Delta T, the change in the time value, is 4 minus 2 equal to 2 hours. You see, the change in the value of time is 2 hours. And during that time, how much did your earning change? You see, after working for 2 hours, you had earned $20. Working for 2 more hours, your earnings went up to $40. So what is the change in your earning? What is delta A? the change in your earning delta A is $40 minus $30 equal to $20. You see, write it as $20. Now, this means when the amount of time you work changed by 2 hours, the amount of money you earned changed by $20. So, if I ask you this question, when time changed by 2 hours, your earnings changed by $20. When the time changes by 1 hour, how much will the earnings change? What will be the change in your earnings when the time changes by 1 hour? That can be done by dividing this $20 divided by 2 hours. That will be, let me do that for you. Now, what will be delta A divided by delta T? The change in the amount of dollars divided by the change in the amount of time is $20 divided by 2 hours, and look at the way it's going to get. It is $10 per hour. You see, this is called your rate of pay. The rate of pay. Slope of a graph is a measure of the rate of change. You see, your rate of pay, you work 1 more hour, you earn $10 more. That is called the rate of change. So your rate of pay is $10 per hour, and that is the slope of the graph. So what does the slope of a graph represent? The slope of a graph represents a rate of change. The rate of change. When you work for 1 more hour, how much does your earning go up? That is the meaning of a slope. So, once you have a slope, once you have a graph, you can use the graph to measure the slope. Now, the vertical values, we normally call it the y variable. And the horizontal values, we normally call the x values. Slope is the change in the y value divided by the change in the x value. Alright, we will practice this. I want you to learn this because it is practiced all over our life. So you must know the meaning of a slope and how to find the slope of a graph. Okay, let's move on. Now, how does the mass m of a substance change with its volume? If you make the mass greater, the volume will also increase. That's a direct variation. Now, density. Now, how many of you know what density of a substance is? Density of a substance is defined as mass per unit volume. If you divide mass by volume, you get density. So density is mass divided by volume. Now, that means if I want to write an equation for mass, can you help me with it? It will be mass equal to density multiplied by volume. Now, if I use variables for this, density D, instead of writing density like this, I'm going to use D for density, and I will use M for mass, and I will use V for volume. Look at the way I'm writing an equation. I have actually 2 variables. Density of a substance is not a variable. Density is a constant. Now, now let me write our previous equation for your earnings below it. Tell me, what was the equation for your earnings? that we developed in the last slide. We have A equal to 10t. Now you notice here that there are only two variables, amount of money and the amount of time. This 10 is a constant. In other words, it doesn't depend on the amount of time you work. Is that right? Your hourly pay is a constant. In the same way, the density of a substance is a constant. It doesn't depend, it's not a variable. If you take a substance like this, you can take a smaller mass or a much bigger mass. You divide the mass by the volume, you get the same quantity for everything. Density of a substance is a constant. So, mass will change, volume will change, but the density will not change. You have mass a variable, volume a variable, but density is a constant. So you can see mass m equal to density d times volume v is a similar equation like A equal to 10t. They are both direct variables. Now, okay. Now, we have mass equal to density times volume. When mass increases, volume also correspondingly increases. This is called a direct variation. Now, how does this compare with the equation of a straight line? How many of you know what the equation of a straight line is? You're supposed to have basic algebra understanding, basic elementary algebra. Look at this. Y equal to mx. Well, I know most of you will ask me, isn't the equation y equal to mx plus b? Well, yes. If I write y equal to mx plus b, it represents a line like this, where b is called the y-intercept. That's your b. Now, if the graph goes through the origin, then that b will be 0. So, if you have a straight line graph that passes through the origin, that b will be 0, and then the equation for that graph will be y equal to mx. Now, how many of you know what that m stands for? M is the slope of your graph. What did I say the slope of a graph is? Slope of a graph is the rate of change. The rate of change. So m is the slope of the graph. If you draw a graph of y on the vertical axis, x on the horizontal axis, then m will be the slope. In other words, if you find a change in the value of y, delta y, and divide it by the change in the value of x, delta x, that will be your slope. Alright. Now the graph of this is a straight line and m is its slope. Alright? Try and understand it well. If I draw a graph of y on the vertical axis and x on the horizontal axis, it will be a straight line passing through the origin. And slope is m. And what is the slope? Slope is a measure of the rate of change of y with respect to x. Slope is a measure of the rate of change. What is the meaning of rate of change? When x increases by 1 unit, what will be the increase in y? In the earlier example we said, when you work for 1 more hour, how much will your earnings go up? That is the rate of change. Now, slope is calculated like this. Change in the y value, we call that delta y, is that right? I told you. Divided by the change in the x value. So So delta y divided by delta x. The change in the y value divided by the change in the x value is a measure of the rate of change. And that is the slope of the graph. And how do we do this? I showed you how to do that. Find delta x and find the corresponding delta y. Now, delta y divided by delta x is the slope of the graph. Alright, that means y equal to mx and mass equal to density times volume are very similar. So, if you now draw a graph of mass on the vertical axis, look at that, mass has now taken the place of y. If you draw a graph of mass on the vertical axis and volume on the horizontal axis, you should get a graph that passes through the origin. And you measure the slope of the graph, that will give you density. Alright? So you have mass on the vertical axis and volume on the horizontal axis. It will be a straight line graph, and the slope of this graph will be a measure of the density. Alright? The slope of the graph of m against v is the ratio of what? Change in mass. Change in mass we call delta m, to the change in volume, that will be delta v. So we represent the change in mass by delta m, and we represent the change in volume by delta v. Then the slope will be delta m divided by delta v. See, the change in the mass is delta m, change in volume is delta v, and the slope will be delta m divided by delta v. Alright. So slope equal to delta m divided by delta v. What does it mean? Change in the value of m divided by change in the value of v. Alright. Tell me, what is the change, what is the unit for measuring delta m? You see, if you measure mass in kilogram, the change in mass will also be kilogram, and volume will be meter cube. So the unit of density will be kilogram per meter cube. On the other hand, if I measure mass in gram and volume in milliliter, I can also write unit of density as gram per milliliter. So density can be measured in kilogram per meter cube or gram per milliliter. Alright. I think we need to do an example. Is that right? Alright. Let's do a lab. We're going to start with a lab. Now remember, when you start a lab, I would like you to hit pause on the video and open the lab worksheets folder. You see, I have sent you all the lab worksheets. Alright. Print out the lab 1 worksheet. Alright. And once that you have in front of you, let's start the work. Lab 1, we're going to learn how to measure the slope of a graph. I'm going to repeat what I did earlier. Alright, so what I did is, I measured the mass and volumes of 5 pieces of copper. I took a small piece of copper, then I took a bigger piece of copper, then a still further bigger piece of copper, and I measured the mass and volumes of these pieces of copper, and I got these values. And look at that, I measured the mass in gram, I measured the volume in milliliter, and these are the values. The first piece of copper has a mass of 80 grams. It has a volume of 10 milliliter. The second piece of copper had a mass of 160 grams. It had a volume of 20 milliliter. And I had 5 pieces of copper. I measured the mass and the volume. Now, what I want you to do is plot a graph of M on the vertical axis and the volume V on the horizontal axis and measure its slope to obtain the density of copper. Well, since most of you are very new to this, I'm going to take you through this process so that you watch me do this and then do it on your own and then make it into a Word document. Now remember, the worksheet I have given you, you can save it onto your computer and then type on it. For example, I've given you this table. You can print out, you can type the values on the table, and later on I will show you how to draw a graph on the computer. Isn't that nice to know? So that you can prepare your lab report as a Word document and email it to me. You see, by the time you finish this course, you will be learning a lot of skills that are necessary. Didn't I tell you, interacting with the world is a skill that you really need to learn. Alright, now here I'm going to show you how to draw this graph. Now this is the x-axis there. I'm going to draw the volume there. I'm going to draw the volume 10 milliliter. Look at the way I'm going to draw it. 20 milliliter, 30 milliliter, 40 milliliter, 50 milliliter, and that is my volume axis, horizontal axis. And on the vertical axis, I can go in steps of 80. See, I have chosen convenient values. That is 80. This is 2 times 80, 160. 3 times 80, 240, so they're actually in steps. And 4 times 80, 320, that's the mass in grams. Now, I want you to practice exactly the same way I'm doing. This is mass in gram, this is volume in milliliter. Now remember, I haven't written that, but I want you to add this. You must label this axis. This is volume in milliliter, so it must look like this. Volume in milliliter, mass in gram. So don't forget that. You must, in your graph, it must read like that. Okay, now let's mark these points. Now the first point is when the volume is 10 milliliter, the mass is 80 grams. When the volume is 20 milliliter, the mass is 160 grams. When the volume is 30 milliliter, the mass is 240 grams. You see marking the point? When the volume is 40 milliliter, the mass is 320 grams. When the volume is 50 milliliter, the mass is 400 grams. I got all the points. Now, this is your graph of the equation M equal to D times V. And how do we measure the slope? Okay, I want you to practice this so that in the next few labs you can do this on your own. Alright, now let's choose 2 points. Let's choose this point, that is 20, 160. And we will choose this one, 50, 400. So to measure the slope of the graph, we start by choosing 2 points. Now, once you have 2 points, this means the volume is 20, the mass is 160. The second point says the volume is increased from 20 to 50. Can you tell me what is the increase in volume? The increase in volume is 50 minus 20. That is your delta V. And what is the increase in mass? 400 minus 160. So let's write that. Now, we draw this triangle to help us to measure the change in volume and change in mass. What is the change in volume? Volume changed from 20 milliliter to 50 milliliter. The change in volume delta V is 50 minus 20, that is 30 milliliter. What is the change in mass? Delta M, I've written it slanting. Now, the mass increased from 160 to 400 gram. So the change in mass is 400 gram minus 160 gram. That is 240 gram. Therefore, what is the slope of the graph? Slope of the graph is the change in mass divided by the change in volume. So slope, density, slope will be the density. So density is the slope of the graph, which is delta M divided by delta V. Delta M is 240 gram. Look at the units we use. Delta V is 30 milliliter, and so the density is 8 gram per milliliter. Alright, complete this work on your worksheet and email it to me, and that's your first lab. Your lab contributes a good part of your grade, so a good way to earn a decent grade. Let's spend some time now talking about direct and inverse variation. We talked about this. When you fill your car, how does the volume of gasoline change with time? Well, the volume V increases with time. And so, if you draw a graph of V on the y-axis and T on the x-axis, what kind of graph will you get? A direct variation. It will be a graph like this. V on the vertical axis, time on the horizontal axis. That will be the graph when you stand there and fill your gas tank. With time, the volume of gasoline increases in your tank. As T increases, V also increases. Now tell me, how many of you can tell me, if I measure the slope of this graph, what information will that slope give you? The slope is the rate of change. Have you noticed if you go to some gas station, you try to, well, you press the lever, it's hardly anything comes out. The rate at which the fuel comes out is very small. Such a graph will be a very flat graph. The slope will be very small. On the other hand, in some cases you just press it and it gushes out. The rate at which the fuel comes out is great. The graph will be a steep graph. The slope will be high. Look at the way the information the slope gives you. Now, can you guess what information the slope of this graph gives? We talked about this, right? Alright, how about inverse variation? When you run your car, you finish filling and you run your car. As you keep running more amount of time, the volume of gasoline will come down. The volume V of gasoline inside decreases with time. So what will the graph of anybody? Can you try this on your own? Now when you start, the volume is full, you got full tank. And as time goes on, the volume in the tank decreases. So if you draw a graph of volume on the y-axis and time on the x-axis, what will be the graph like? Alright? Well, let's draw that graph. Now when you start with, this is the volume and that's the time. When you fill, that's where you are, and with time the volume decreases, and if you're not careful, after a certain amount of time you will have nothing left. Alright? Now, what is the difference between the red and the blue? Anybody tell me? This blue will use up gas much faster than the red. You have an SUV, that is your graph. Is that right? So the difference between the blue and the red is the rate at which the fuel is used is greater here. You can see again, that's a measure of the slope. This has a greater slope than this. My little Toyota Corolla gives me 40 miles per gallon, and I fill only once in 5 weeks, whereas somebody driving a Ford Explorer will fill every week. Now look, the rate at which you spend energy is an important indication of how fast we are using up our energy sources. I want you to develop some social concerns and social values as part of this course. Alright, so try and conserve energy. That is an important fact. Alright, what does this represent? If you fill the tank and the line is a straight line, horizontal line, what does it tell you? It tells you that you filled the tank and you left it there, never used the car, right? Well, I hope this is the introductory lesson, and I hope you are now prepared for the full course, and I will see you for the next lesson a little later, all right?